If you didn't get to finish reading that, that's okay. I'm just going to do a demonstration with something I've set up here. So this is our pretend town. So we got some cars, we've got a building, and we're just going to see what happens when we apply different kinds of waves to it. So you guys heard about P waves, S waves, Raleigh waves, and love waves. So the whole point of this is that earthquakes can move in different ways. Earthquakes can move the land in different ways. So P wave, you see here it says that you have expansions and compressions. So basically the wave is just kind of moving straight through the land. Mm-hmm. So this would be like me just kind of pushing this track in one direction. And so got a little bit of damage there. My building kind of fell apart, but the cars are still there, more or less. S wave is kind of like a Ripley effect, kind of like what you see out of an ocean wave.
Yeah.
So, like, well, that wasn't very good. Let me try that again. I didn't practice this, actually. So a little more damage.
But that's basically what has happened.
I wouldn't say that, because this is a demonstration. I wouldn't say this is an accurate model of the Earth. I'm just kind of trying to show you guys what these are. I can't really demonstrate Raleigh waves very well, because Raleigh waves are kind of like rolling waves.
Okay.
Since I just have a rubber track, I would need like a big bowl of Jello or something to even try something like that. But love waves they move forward, but they kind of move things side to side.
Okay.
So instead, S wave moves things up and down. This one moves things side to side. That can be like me rocking like that a little bit. Mm-hmm. So those are different types of waves. And I just hope that kind of helps you visualize what they would look like. Now, one thing that's kind of cool to think about is that most earthquakes come with P waves and F waves. Actually, I'm pretty sure that all earthquakes have P waves and F waves. P waves can travel through solid and liquids. S waves can only travel through solids. Why do you think that would be significant for us to know? Why do you think it would be good to know that this travels through solids and liquids, but this only travels through solids? Any ideas? Yeah, that's true. Do you remember when we talked about the layers of the Earth? We have 4 layers of the Earth. Most of them is solid, but isn't one of them a liquid? Yeah, so do you guys remember which layer of the Earth is a liquid? I know I'm kind of jogging your memory a little bit. It's really hot. It's melted. Not the mantle, the one right out there.
Not the episode.
Yeah, close. So the outer core, there's an inner core and outer core. The outer core is basically, it's called the outer core.
The outer core.
So, this is important to know because waves travel differently. We're talking about waves here. Waves travel differently through different substances. Have you guys ever seen something like this where you have like a straw or a spoon in a glass and it looks like it's the hardness of the water isn't really where it should be?
Yeah.
This is called refraction.
Okay.
So light travels more slowly through water than it does through air. And because of that, when you put something halfway into water, it looks like it's kind of shifted, even though it really did shift. But when we're talking about earthquakes, because P waves can travel through, so I think the green arrows here are S waves, P waves are the purple. P waves can travel through solid and liquid, but they refract. When these P waves refract, they leave these things called shadow zones. And remember I said whenever we have an earthquake, it can be felt all around the world because we have so many earthquake stations around the world now. So if an earthquake started here, somebody on this side of the globe wouldn't detect it. They also can't detect it over here. Those are the shadow zones, and those let us know exactly how big this outer core is. Mm-hmm. So just by measuring earthquakes over long periods of time, we can determine how big the core of our planet is. Which is really important because it tells us a lot about the history of the Earth, tells us how long it's been around, tells us about what's going on inside. So our earthquakes actually allow us to study the inside of the Earth. Any questions about any of that?